We're going to calculate the expansion work when 0.5 moles of water decomposes to form oxygen and hydrogen. And we are given a temperature and told that it's at constant pressure. Expansion work for gases means we're going to combine these two equations where work is equal to the negative pressure times the change in volume, and the ideal gas equation, which means pressure times the change in volume would equal the change in moles times RT. So here and here is where we can substitute this equation, which is going to give us this equation. Work is equal to the negative delta N of RT. So delta N is going to be the moles of products minus moles of reactants, but we only do this for the gases in the equation. And we'll actually be told that you have 2 moles of water as a liquid, and it's going to yield 2 moles of hydrogen gas plus 1 mole of oxygen gas, because we're actually still going on the same equation from the first example in this series. So now that I know what my delta N is, we can solve the equation where work is going to be equal to negative, and then N is 3, my change in moles, times R, and R is 8.314, which is joules per mole Kelvin. We use this value for R anytime we're solving for work because we want to know in terms of energy. So this will be multiplied by the temperature, which is 298 Kelvin, and we get negative 7,432.716 joules of work. This is not our final answer, but it is an important answer, so I will circle it. However, this is the joules of work that occurs when 2 moles of water is decomposed. And the question is asking about 0.5 moles of water. So I still need to go ahead and stoichiometrically figure this out for 0.5 moles of water. So we're going to say 0.5 moles of water, and then because of this, for every 2 moles of water, this reaction does negative 7,433 joules of work. And so when we take this value times 0.5 divided by 2, we get negative 1,858 joules, or if we change it to kilojoules, it would be negative 1.858 kilojoules. And this would be our final answer. So always be careful and recognize what your answer is representative of, and you may have to do a little stoichiometry to modify any answer of work or delta H that you might get in future questions.